In this slide, we'll show you some examples that the Z-transform and DTFT are not the same. And they are not the same when the region of convergence does not include the unit circle, and we cannot simply take the Z-transform of the signal and convert them to DTFT. And in fact, there's a very strange phenomena. The most common signal that you think, which is the sinusoid, actually does not have a Z-transform. And why is this so? Well, if you take the cosine can be broken down into two parts. One, the causal part. So this is the causal signal, the cosine, and this is the anti-causal. And then if you take the Z-transform, and it exists, of course, this Z-transform exists here, and this Z-transform exists, but the region of convergence do not include each other. So the ROC is empty, and if the ROC is empty, it means that the Z-transform of this cosine omega n does not exist. But then, but of course, the DTFT of sinusoid exists, and the reason why DTFT of sinusoid exists is that the DTFT uses the delta function in the analysis and synthesis, and the DTFT of the sinusoid is simply this equation over here for all values of k up to infinity. But if we ignore the region outside minus pi to pi, then we are seeing that there are two deltas sitting at omega naught and minus omega naught, with pi over j for the coefficients for sine. So please don't be confused. The Z-transform and DTFT are the same only when the ROC includes the unit circle. If it doesn't, you cannot use Z-transform as DTFT expression. However, because the DTFT uses delta functions, then it realizes the sinusoids, even though it lasts from negative infinity to infinity. And the other problem which you might face is this: if you have a signal x of n, and this x of n is a causal signal, and therefore it will have a Z-transform, and then you try to take the DTFT of this signal, and it is a very complicated expression. So it looks something like this on the bottom here. And you realize that the DTFT of a sine that is causal looks very, very complicated, right? And the DTFT of a unit step also look very complicated. This expression plus pi with some impulses. But however, in the Z-transform, the unit step is very simple, and the Z-transform of the causal sine is also very simple. So the quick answer to you is, please remember that they are slightly different, and typically we'll use the one that is simpler to solve the problem. So if it's easier to use the Z-transform to solve the problem, we'll use the Z-transform. If it's easier to use the discrete time Fourier transform, you use the discrete time Fourier transform. That's all. Thank you.